Welcome to your Finite Math R7 lesson on radicals. Our objective today is to simplify radicals. So an expression in simplest radical form means that that expression is written such that the radicand of the nth root contains no nth powers as factors, and there are no radicals in the denominator. All right. Simplify, leaving your answer in simplest radical form. Do not use a calculator. Assume all variables represent positive real values. So we've got the square root of 100a to the 12th power. Now whenever you have a plain square root, there is an understood index of 2. So we want to get both factors written as something to the second power. Well, 100 is 10 squared. And a to the 12th can be written as a to the 6th to the second power because 6 times 2 is 12. So what you do in a case like this, because this is a square root, you put the 2 out here, and then you go, okay, 12 divided by 2 is 6, and you write a to the 6th on the inside. All right, the 10 can hop outside, the a to the 6th can hop outside because they have been raised to the second power on the inside of a square root sign, so it simplifies completely to 10 times a to the 6th. All right, for part B, we've got square root of 18 times square root of 12. Now we can try to simplify each one separately, but we might as well just put them underneath one big happy square root sign since they were being multiplied together. So we've got the square root of 18 times 12. So let's think of perfect square factors of each one of these because they're not perfect squares themselves. 18 is equal to 2 times 9, and 9 is 3 squared. So I'm going to write 18 as 2 times 9, and 12 is 4 times 3, and 4 is 2 squared. So I rewrote 18 as 2 times 9, and 12 as 4 times 3. You may be wondering, well, why didn't I just multiply 18 times 12? Remember, I'm not working with a calculator, and that's more complicated than going ahead and breaking it down, and we want perfect square factors anyway. So 9 is 3 squared and 4 is 2 squared. So since this 3 is squared, it gets to hop outside. This 2 is squared, it gets to hop outside. This 2, the very first one, is not squared, so it's got to stay underneath the square root sign, and so does this 3. So I'm going to have 3 times 2 on the outside times the square root of 2 times 3. So that's going to give me 6 square root of 6. And that's my final answer. Okay, I've got the square root of x to the 4th times y cubed. Okay, again, it's a square root, so I want to write things as something squared. I can write x to the 4th as x squared squared. And then y to the 3rd, I can break off a y squared, and then I have a times y. Remember, there's an understood first power there. 2 plus 1 is 3. So y cubed can be written as y squared times y. All right, the x squared is squared, so it gets to come outside. This first y is squared, so it gets to come outside. The second y is not squared, so it stays under the square root sign. So we have x squared y times square root of y. All right, example 2, still simplifying. This time I've got a plus here. The only way you can add two radical expressions together is if you're taking the same kind of root, so both square roots, both cube roots, that sort of thing, and the radicands are the same. So the information inside the square root is the same. So at first this may look like you can't add them together because we've got square root of 12 plus 2 times square root of 48. They're both square roots, but one has a radicand of 12 and the other one of 48. But they can each be simplified. Okay, so what we need to do is simplify each term individually and then see if they're like terms, and we can simplify even further by adding them together. All right. 12 has a perfect square factor of 4, so 12 is equal to 4 times 3. We can write 4 is 2 squared. And then our plus 2 times the square root. 48 is 16 times 3, and 16 can be written as 4 squared. So 48 equals 4 squared times 3. So in my first term, the 2 can come out, and so I'll have 2 square root of 3. In my second term, the 4 can come out, so I'll have 2 times 4 times the square root of 3. 2 times 4 is 8, so I've got 2 square root of 3 plus 8 square root of 3. All right, they're both square roots. They both have radicands of 3, so I can add them together, and I just add the coefficients. 2 plus 8 is 10 square root of 3. All right, I've got 3 times the square root of 125 minus 2 times the square root of 80 plus the square root of 405. All right, so I want to try to simplify this. Remember, you simplify each term individually, and then you try to combine like terms. All right, 125 is equal to 5 times 25. Okay, so 25 times 5 there, minus. Now let's see if I can write 80 as something times 5. Well, 80 divided by 5 is 16. Oh, and that's great because 16 is a perfect square. So I'm going to rewrite 80 as 16 times 5. I'm going to do the same thing with the 405 and go, okay, I see this pattern where I've got 5 as one of my factors. So 405 divided by 5 is 81. 81 is a perfect square, so that's going to work out really nicely. All right, so I rewrite the 25 as 5 squared, the 16 is 4 squared, the 81 is 9 squared, and I see what gets to come out of each square root. So I'm going to have 3 times 5 times the square root of 5, minus 2 times 4 times the square root of 5, plus 9 times the square root of 5. So I have 15 square root of 5 minus 8 square root of 5 plus 9 square root of 5. So 15 square root of 5 minus 8 square root of 5 is 7 square root of 5 plus 9 square root of 5 is 16 square root of 5. Example 3, we're going to multiply. I've got 2 square root of 3 minus 4 times 3 square root of 3 plus 1. Now this is just a number times another number, but they are written as binomials because you've got a radical term and a non-radical term and you can't simplify any further. So when we multiply, we have to FOIL these out. So I'm going to have 2 square root of 3 times 3 square root of 3 plus 2 square root of 3 times 1, and then either plus negative or it's just easier to write minus 4 times 3 square root of 3 and then minus 4 times 1. Alright, so I've got 2 times 3 is 6 times the square root of 3 times 3 is 3 squared plus 2 square root of 3 minus 4 times 3 is 12 square root of 3 and then minus 4. Alright, let's see, we need to bring this 3 out, so we'll have 6 times 3. 2 square root of 3 minus 12 square root of 3 is minus 10 square root of 3 and then minus 4. 6 times 3 is 18 minus 4 is 14, so 14 minus 10 square root of 3. Alright, look here, we've got square root of 5 minus square root of 3 times square root of 5 plus square root of 3. Do you remember what these kind of numbers are called, where you've got the same terms but one has a minus in between and one has a plus? Yep, they're conjugates. Those two are conjugates. And remember, something interesting happens when you multiply conjugates together. Let's see. We're going to FOIL and see what happens. All right, so I'm going to have square root of 5 times square root of 5. So square root of 5 squared plus square root of 5 times 3 is square root of 15 minus square root of 3 times square root of 5 is square root of 15. And then minus, because we've got negative times plus, square root of 3 squared. Look what happens to the middle terms. Square root of 15 minus square root of 15 zeroes out. That's the cool thing that always happens when you multiply conjugates together. The middle terms cancel out. Another cool thing happens. Square root of 5 squared is 5 minus square root of 3 squared is just 3. You get 2. You end up with a number that is not a radical. And so that's really kind of cool that you end up with just a really nice integer value there. And the reason that's important to us is it's going to help when we get to more complicated things, similar to example 4a here. Remember, you can't leave a radical in the denominator. You can't have a rational exponent, an exponent like x to the 3/2 or 5 to the 1/2. You can't have that in the denominator either, because that's just a radical in disguise. When it's just a simple square root of 7, something like that, remember you just multiply on top and bottom by that same value. So I'm going to multiply on top and bottom by square root of 7. I'm going to end up with 3 times square root of 7. On the bottom I have square root of 7 times 7, so square root of 7 squared. Square and square root cancel, and you get 3 times the square root of 7 over 7. And so you've rationalized the denominator. You've gotten it where you don't have a square root in the denominator. Now, here's where we're going to bring conjugates back in. We've got 4 over square root of 5 minus 1. Remember, if I multiply by the conjugate, not only do I get rid of the middle terms, there will be no more radicals left. So I'm going to multiply on top and bottom by the conjugate of square root of 5 minus 1, which is square root of 5 plus 1. So on top I'm going to have 4 times the square root of 5 plus 1. On the bottom I'm going to have square root of 5 times square root of 5, which is going to be square root of 5 squared, which gives me 5. My middle terms are going to cancel out. I'll get square root of 5 minus square root of 5, so those will zero out. And then negative 1 times 1 is negative 1. 5 minus 1 is 4, so I can cancel the 4 on top with the 4 on bottom, and I'm left with square root of 5 plus 1. Okay guys, that's it for your examples. Make sure you try the problems to try on your own. Come see me if you need help. Thank you for your attention and time and effort in watching the video and taking notes. And I will see you in class soon. I hope you have a great day.